So in my previous video, I did a kind of quick run through discussing how fixed point notation works. But in this video, I'm going to go over how floating point notation works. Now, to help you understand this a little bit better, we're going to start with looking at how our numbers work generally when it comes to working with denary numbers. So for example, all right, if I've got 2.71 and I multiplied that by 10 to the power of 4, what that actually means in terms of the notation would be, all right, 27100.0. Let me show what's happened with that. So it's moved 4 places. So that has gone 1, 2, 3, 4. So we know that's how that works with denary numbers. Well, actually, it's exactly the same principle with binary. Okay, so with binary, it is the same principle. And what we have here is we're going to write a binary number out. Okay, so we're going to start with 0.1110, and we're going to go for 10. Okay, and we're going to multiply that by 2 to the power of 4. Alright, so let me show you what happens here. So this is equal to 0.010. Now what has happened, so you can visualize this, is the decimal point is always here and it's gone 1, 2, 3, 4. See how that's moved? So let's write that out. So you've got 1, 2, 4, 8, 16. You've got your decimal point here. You've got a half, a quarter, and eighth. So what we're going to do is write this out. We've got 0, 1, 1, 1, 0.010. Now we know that that is 8 plus 4 plus 2, which is equal to 14 and a quarter, or you could have written down 14.25. Let me draw a line for that. 14.25, because we know that that should have said a quarter there. All right, so we know that that's 14 and a quarter, and that's what that ends up like. Just so you are aware, all right, I'm going to write this out again. 1110.010 times 2 to the power of 4. What we have here is this is the mantissa. This is the number that we start with. This, however, is the exponent. And it's this number which says whether we are moving to the right or left. Alright, because believe it or not, this can actually be a negative number. Alright, we're going to do another example of this. So I'm just going to move this here. So we are continuing on with our floating point. notation. So this time, imagine we've got a 12-bit number with an 8-bit mantissa and a 4-bit exponent. What we're going to do is start off with 0, 1, 1, 1. And we're going to go for, so this is 12 bits, let's go for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we are going to have a 4-bit exponent. So this is our mantissa, and our exponent is 0, 0, 1, 1. Now imagine we've got this number. The best way to help you with this is we've got to assume, alright, that the decimal place always starts between the first 2 digits. So that's here. So that's our decimal. Alright. The other thing we've got to assume is we've got 1, 2, 4, alright, and so on. So in this case, the exponent was 3. Alright. Multiplying by 3 will have an effect on moving this 3 places to the right. Because it's positive, alright, positive, it's going 3 places right. Notice we haven't written the values up here just yet. So we're going to go, well, let's write this out again. So I'm just going to write the number out. 1, 2, so 4, 5, 6, 7, 8, 9, 10, 11, 12. So if this is moving 3 places to the right, it's going to go 1, 2, 3, and it's going to end up here. Alright. So this is now going to give us, alright, the value. Let's write that out. 1, 2, 4. This is now going to give us the value 7. Alright. Obviously, I've not put any decimal places. I've tried to keep that easy to begin with, but now let's do one with a decimal. So this time, I'm going to write out the number again. Alright. And we're going to go 0, 1, 0, 1. And we're going to go 1, 1. So what we're going to do is, so this is going to be 12 bits. So was it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to write my exponent out. All right, and we're going to do this by, let's do it for 3 again. 1, 1. So that exponent is 3. Alright, the decimal place starts here, so it's going to go 1, 2, 3. So this is going to be 0, 1, 0, 1, 0.11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But this time around, you're going to go 1, 2, 4. We know the value this side is 5. We've got a half and we've got a quarter. So that would be 5 and 3 quarters, or 5.75. So that's how this works. Remember, once you've worked it all out, alright, you can actually draw them. You can draw a line through them, and that basically means that you can kind of use that as a visual for yourself, so that you know how that you've done the 3 places. So each time you count up how many places you've moved, you can draw a line through them and work that out. But now, obviously, there's going to be another video that shows you how you can represent this in 2's complement, because at the moment we've not really demonstrated that, and you also need to know what 2's complement is, so we will follow up with that in our next video.